This is the Pearson EDEXCEL IAL, Pure Math 1, June 2022. The question 5, I already did a previous video, so I just want to do another video for this question 5, dealing with quadratic, specifically with the quadratic function. So let's take a look. There's some other ways we can solve question 5a. Right. So we're just doing question 5a for this video. In the previous video, you can go take a look. I did a ABCD thing where you use simultaneous equations to solve for the function. But in this question, I want instead to look at alternative ways to do it that might be a bit quicker. Okay, so if we look at a quadratic function, this is general form. So a quadratic expression in its general form is ax squared plus bx plus c. But then we have two other forms that we could have it in. So we could have x-intercept form, which is a, and it's x minus our first x of our first x-intercept, and x minus the x of the second x-intercept. So if these are x-intercepts, would be x1, 0, and this is a 2. The other x-intercept, x2, 0. So where y 0 is our x-intercepts, and of course x and y are the usual subbing in a point that's on that function. Okay, then the third way we can do quadratic functions is turning point form. So this was x-intercept form. And then we have turning point form, which is, you can read the turning point directly off this form. So it's just a square that has been contracted. So in this form, PQ is your turning point, where P is the opposite sign because it's inside the bracket connected to X. So it's counterintuitive. And Q is the same sign. Okay. So Q would be the same sign and P would be the opposite sign. Right. So how can we use this information to quite quickly in two different ways sort out this problem? This was turning point form. So first we're going to look at the x-intercept form. Here we have an equation for a quadratic that looks something like this. And they've given us the turning points of our quadratic C, that is -2, 12. And they've given us that perhaps there'll be an x-intercept, or that not perhaps, that there will be an x-intercept. And if you look at the turning point, there's a -2 in the turning point. So the x-intercept that they've given us of -5 will be to the left. Okay. Now, quadratics have a line of symmetry, goes down the middle like this. So if we look at that line of symmetry, we say, well, how far away is our turning point x from our x of our x-intercept that we've been given? Well, it goes from -5 to -2 is +3. And because of this line of symmetry, another +3 will get us to our other x-intercept. So we say -2 + 3, which is 1. Okay, so we have two x-intercepts, and our x-intercepts are -5, 0, and 0, 1, using the properties of symmetry. Now, the x-intercept form was y equals a. Don't forget the a. X minus the x of x1, x minus the x of x-intercept 2. So let's sub everything we have in to this. Let's take a look. We have our x-intercepts are here and here. And then we have our turning point. Our turning point is up here in light blue. Okay, so the turning point is going to be the point that we sub in for y and x. And the x-intercepts are going to be the points that we put just the x's of the x's. So how does this work? Well, the turning point is y is 12 is equal to a, which is our unknown still. Our first x of the turning point is minus 2. Now we have minus x1, so it's minus 5. Then we have our turning point x again, minus 2, and minus 1 is our other x-intercept. So we've used these, this, and this. You need 3 points for this method to work. I would quickly just clean this up a bit. So we have 12 equal to a, minus 2 plus 5 is minus 3, minus 2 minus 1 is 3. So 3 times negative 3 is negative 9. Negative 9a is equal to 12. Divide through by negative 9 on both sides. And a is equal to 12 over negative 12 over 9, which is negative 4 over 3. If you divide 12 by 3, so you can divide this by 3 over 3 in order to get the simplest form. Okay, so we have our a value. Now we're not done. We needed the question asked for ABC. So the question had, what is y equals ax squared plus bx plus c? So just another common error I see a lot. This a is not the same thing as this a. So these two a's are not the same. Okay, they're not equal. Not equal. No. Okay, not. So of course, sometimes they are. I'm just trying to think like I'm just looking at this one. In this case, they are. I think in this form they can be, but anyway, don't assume. Don't assume. We need to times it out. So what do we do next? Just let's make this don't assume anything. Let's make that don't assume. Okay. So we have to sub this back into our formula. We have our a value. Now we used the turning point here. We used the turning point to figure stuff out. So if we had y equals a, x minus x1, x minus x2, and we want to sub in the a that we got, it would be, well, y equals to minus 4 over 3. And this x that we subbed in the turning point is actually part of the general form, so it stays there. But we still have that x1, which was minus 5, minus 5, which would end up being a plus 5. And x2, the other x-intercept, is minus 1. Okay, so this is what we need to times out. Let's just quickly make it look a little bit more. So x plus 5, x minus 1. Good. So these just now becomes a matter of timesing this out. So minus 4 over 3, do the brackets first. X squared, outer is minus x minus 1 times x. 5 times x is plus 5x, and the last is minus 5. Okay. So whatever your method is for timesing out. And then we go minus 4 over 3, just doing all the steps here. So x squared plus 4x minus 5. And last step here, we times it in. So 4 over 3, minus 4 over 3 times x squared is minus 4 over 3x squared. Minus 4 over 3 times 4x is minus 20, 4 times 4 over 3x. Minus 4 over 3 times 5. Minus 4 over 3, that's not 20, it's 16. because the next one's 20, so that's self-checking. It can't be 20. Okay, so the minus 4 over 3 times minus 5 is positive 20 over 3. And this is the correct answer. Okay, so that was the x-intercept method. Now we're going to take a look at the turning point form method. So for turning point form, we had this, y equals a. Again, don't assume that's the same a, although in the other one it turned out to be so. X minus p squared plus q, where p and q is our turning point. Okay, so it's our turning point xy, where x is the opposite sign, and y is the same sign. Okay, so we had our minus 5, 0 as one of our points, and 1, 0 as another one of our points. And then we had the turning point, which was minus 2, 12. So let's start with subbing in the points with the, so we look at the turning point minus 2, 12. This will go where P is, only the opposite sign, and Q. And then if we look at, we can choose one of these points, and let's choose the one that was given. So we used symmetry in the previous question, but this was actually given to us, this question. This was in the question. So always try and use the given information if you can. And that's going to be your X and your Y. That's it. So we don't need to use our own, we made this, we made this, okay, with symmetry. So this method only needs these 2 points, which is quite useful. Let's start subbing stuff in. So we start with the y of the x-intercept is 0. And then obviously our a is the unknown that we need to solve for. The x of the x-intercept was minus 5. Minus p, well, our p was minus 2, so it'll be plus 2. And squared, don't forget the squared. And our q was 12, same sign. Okay, so minus 2, a, 0 equals to a, minus 5 plus 2 is minus 3. Minus 3 squared plus 12. And then we have minus 3 squared is 9. Minus times minus is a plus. 9a plus 12 equals to 0. See, getting the same a value, which is really debunking my idea, but just don't trust. Nonetheless, a standby. Don't assume it's exactly the same thing. Okay, so minus 12, rather prove. Don't assume, rather prove. 9 equals a. So a is minus 4 over 3. Right, so we have back to the same a value, but for this method, you have to sub it back into the turning point form. I write the turning point form over here. The turning point form was y equals a, x minus b squared plus q. And we're subbing in this a, and we're subbing in another point. We're subbing in our turning points, because those p and q is unknown parameters. We need to sub that in. So we take a y equals minus 4 over 3. X we leave because in the general form it stays like that. So minus p was plus 2 squared plus 12. Okay. Now we just want to, the last step is to put it in general form. So general form, first do the brackets, minus 4 over 3, x squared plus 2 times x times 2, because there's 2 of them. 2 times x times 2 is 4x. Oh, just because of this. When you do outer and inner, there's 2 x's. Okay, plus 4, plus 12. Now I have to times in the minus 4 over 3. Minus 4 over 3 x. 4 times 4 is 16, negative 16 over 3x. And then it's negative 4 times 4 is 16 over 3 plus 12. Well, for the constants, we probably need a common denominator. We're almost there. Common denominator of 3. So 12 times 3 over 3, 12 over 1. 3 times 12 is 36. So we have minus 16 plus 36 all over 3. And this is 20. So this, hang on a sec, this minus is up here because it's minus 16 plus. So we would more correctly write this like this, okay? And the final answer becomes to 20/3. So we see that in the end, we got to the same answer in 3 different methods now, the first method being in the other video that I made on this question. Okay. So that was doing quadratics equations, solving for quadratic equations via the turning point form and the x-intercept form, which actually, if I look at this question, is maybe both a little bit more suited for this this question. So here's the information, and good. I think that's the end of this question. We're only doing 5A. If we want to see the rest of question 5, go back to the other video. I'll put it in the description. Okay.